Okay, welcome to the programming lecture. So I am very excited to teach you Python if you have not learned it before. It's a very fun language, and let's get started. It is a very popular one as well, so it's a good one to learn first. It's a very common one that most schools use to teach first, in fact. So the very first step, of course, is to download Python because it is a program. Okay, so I want you to go to this website, python.org/downloads, and download Python 3. Okay, there is Python 2, but we do not like that one. That is the old version. Okay, so you're going to download Python 3, and that should be that. Okie dokie. So download that, version 3, not version 2. If you do not feel like installing things, or like you're on an iPad or something where you cannot install it, there is this thing called Reppl.it that you can make an account on, and then you can create, if I do this, Python with turtle, that one will eventually work. You can say create Reppl, and then you can follow along, but I really encourage you to instead download the actual thing. That's how I'm going to explain it. This is very slow, okay? I do not recommend that website, at least when you're starting out. So definitely try to download this program, and then once you have it downloaded, it's going to look like this. Boop. Go into your applications folder on a Mac, or into your start menu if you're on Windows. Here is Python, the Python folder. It made Python 3.9 for me, and I want you to click on idle. Okay, so Python 3.9, 64-bit. I assume it'll look something like that. Don't click on Python itself. Click on idle. Okay, it's going to run Python for you, but in a fancy way. Okay, and I guess now is probably the time for me to tell you, like, this entire language, it's a pun. It's not Python the snake, but Python as in the Monty Python comedy group. Okay, so maybe you've heard of them, and now you enjoy the pun, because Eric Idle was one of the members of that group. So it's all coming together now. Okay, so that's Python, that's idle. And so this is what idle looks like. It's very unassuming. It's got these 3 lines with a cursor, and so you can start typing there. Okay, and that is what is called the Reppl. Okay, so I'm going to teach you how to use this fancy thing. What Reppl stands for, that's what Python is giving to us right now. It's called a Reppl. It's waiting for us to type, because Reppl stands for read. First read what you type, then evaluate what you just typed, then print out the result, and it's a loop. So do all those things over and over again until you're tired of it and you close the program. So that's what Reppl stands for, and let us get started with some Reppl stuff. So yeah. Maybe we should first, like, go down to earth and talk about what is Python, just at a very high level. So it is a programming language, of course. I'm trying to teach you how to program. It's very similar to Scratch, except that it's not graphical. Okay, code isn't blocks anymore. It's just lines of text. So let me maybe draw that very quickly. So instead of, like, you have 2 blocks that fit together, instead, in Python, you have 2 lines that come right after another. So this is like the first thing, this is the second thing, first thing, second thing. You translate that to, like, line 1. You translate that to line 2 in Python. So it's just 2 lines that come after another, and those execute in order. Okay, so it's going to look like English, and then it's going to get really weird, because how in the world am I going to do an if? Like, if else. There's the if part, there's the else part, maybe. What in the world's going to happen to that? How do I, like, put stuff inside when it's just lines? Don't worry, I'm going to show you everything. But I just want to get you started, get your brain moving. Okay, so it is just lines of text. And so if you want 2 things to happen, one after another, sequentially, you just put those 2 things right after each other. Put those 2 lines, okay? Those 2 lines right after each other. Okay, yeah. Every line in Python that's valid, that actually makes sense, that's speaking the language properly, it has a specific meaning and it does something. Okay, and I'm going to teach you those different kinds of lines that you can write. And because it's just text, it's very possible for you to speak it wrong and for your lines to not be valid. Okay, so that's unfortunate, because Scratch, anything that you do, like, will run. It might not be the right thing, but it will run. In Python, you can speak it incorrectly and it won't even run the program. Okay? So I'm going to teach you how to do it right, and also how to read the error messages, because we all make mistakes. It always happens. Yeah, Python is going to complain to you if you make errors. Okay? That's the idea. It will complain. Okie dokie. So I guess the first thing that I want to show you is in the Reppl, just doing some fun stuff. All right, so here I am in the Reppl. I can start typing things and hit enter, and it will evaluate. It'll have read it, evaluate it, print it, and then go right back to another prompt, like, okay, I'm ready to do more stuff. And this was, of course, not a valid line, so it's like, what in the world are you talking about, dude? Let's give it some valid lines. The simplest one is just a number. So a number itself evaluates to itself, and so obviously you got your 2. We have more things. There is 2 plus 2. Of course, we have 4 stars for multiplication. It's easiest to type. So 2 times 3, that's 6. I don't have to put spaces even. 2 times 3 is 6. We can do division, like 2 divided by 3. It's that. I don't know, 50 divided by 42, 50 divided by 2. You see, sometimes it goes in. Percent sign for remainder. So what it does, it's called the modulo operation. I might have told you about this before, but this is what it means. Short for modulo, or modulo is short for that. It's like you do this, and you have 2 things, like x and y on both sides. It does x divided by y and gets the remainder. Gets remainder after dividing x by y. Okay, hopefully that makes sense. So for example, 12 mod 2 is 0 because there is no remainder after dividing 12 by 2. It goes in 6 is clean. But 11 mod 2, 11 divided by 2, get the remainder, 11 modulo 2. That is going to be 1 because if you divide 2 into 11, it only goes 5 times to get you 10, and then it has 1 left over. That's the remainder. Okay, so you can do this for large numbers, and you can get values. Okay, that's remainder, plus and minus, of course. And you can have negative numbers, so like 3 minus 5. That's a thing. You can also do to the power of, like, and that's 2 stars. It's not the caret, it's 2 stars. So like 2 to the power of 4, that's 16. I don't know, 7 to the power of 42. It's apparently that. Numbers can get large in Python, which is very nice. If you're coming from like C++ or Java, and you've already programmed before, you might be a little wary of this and that you can't fit every number, but Python can fit every number. It gives you as much space as is necessary to hold the number. Don't worry if you haven't programmed before and this makes no sense to you. Python is great. You can make any number as large as you want. Okay? So that is some simple operations that you can do on the Reppl, and I have been working with only numbers so far. Okay, so all of these things I've been typing on this Reppl are just numbers, but there are different kinds of things, more than just numbers, and so let's talk about those, different types of things. I like to explain these types as clouds. Okay, so forgive my drawing abilities. Let's talk about things. So think of these 3 things that I'm about to teach you like little clouds that hold a bunch of different kinds of things. So the int cloud, we will say, those hold whole numbers because int stands for integer. Okay? So we can say 42, negative 12, 13, 0. All of those things are integers, and I've been showing you a lot of those here in Python. So like 7 is an integer, 8 is an integer, negative 42 is an integer, and you can even ask Python, hey, what type are these things? You can ask it and it will say it's type. So I say type of 42. Oh, it's int. Yes, yes, yes. That makes perfect sense. Okay, so that is the int type. And you can do this whole, you can always say type of blank in Python for it to tell you what kind of thing it thinks what you give it is. There are more clouds though. The next one is float, which means decimal numbers. So you have things like 3.14, that's a float. Negative 25.9999. that is a float. Things with decimals are floats. Of course, you can have them 2.0, that's totally fine, but as long as there's a decimal place involved, it is called a float. And let me prove that to you. So like 3.14 squared, that's another float. Type of 3.14 float, and float stands for floating point, which is like, okay, this decimal place, it can exist anywhere, it can float all around the number line. That's the idea, I think. It's a weird little name, and I can explain it more in office hours if you're curious. Okay, finally, there is string, and I'm excited to teach you this because it is a bit different to the others. It's not a number. So this is int, this is float. Let me show you stir. Stir for string. Strings are words or characters and sentences. It's just a bunch of characters, okay? And they have to go between either double quotes or single quotes. So like, hi mom, that's a string, we say, like a string of characters on like or beads on a friendship bracelet or something like that. That's why it's called a string. And you can either use single quotes or double quotes. Python doesn't care. So there's one with single quotes, there's one with double quotes. That is stir. And let's see, let's talk about that. So like, hello, hi mom, things like that. The quotes have to line up, you can't do this. That's wrong. Gotta pick one and roll with it. Okay, so that's those are strings, and you can actually do operations on them in an interesting way. So plus and times, those work for strings, weirdly enough. Let me show you. So like, hello plus mom equals, oh, it puts them right next to each other and makes a bigger string. Cool. All right. Times also works, but one thing that you might have noticed is you have to add a space in one of these. If you want one of them to have a space, it has to be like this or like this. Okay. So now it says hello mom with a space in between. So those are strings, and then times works as well. So like, hi times 7 is this. Hi 7 times. That makes sense. It's like, that's exactly what plus means. It's just plus it a bunch of times, right? Cool. So yeah, string times int is completely different from int times int, as I'm sure you have just experienced. Okay, so those are types, and I can say type of hi. Yeah, that's stir. Makes sense. Okay, so those are all your little types that you can use. There's plenty of more types to be used, but those are enough for now. Okay, so now I want to do a little bit more. Let's get into printing and variables and input, and let's go beyond the Reppl. Are you ready? Are you ready? So we're going to make a real Python program. This has been like baby steps, but we are ready to leave the Reppl and write real programs. Okay? So all a Python program is, it's a bunch of lines of Python statements. All the ones that I've been typing, those are correct lines. That's correct Python. I guess one of or two of them had errors, but other than those, that's correct Python. And these lines are going to execute one after another, just like in Scratch. That's not a problem. And let me make you that classic Hello World program now. So I'm going to make a Python program that prints Hello World to the screen, and then I'm going to talk about it. So in Python, because we're writing files, those files tend to have certain names. And customarily in Python, you write your program in a file called, well, whatever you want to call it, as long as it ends in .py. That's the Python file extension. Okay, so as long as you do that, all of your computer will understand. Like, oh yes, if I double click on this, it needs to be opened up in idle. This is a Python source code file. Okay, it doesn't have to be like this, but this is the convention. Okay, and so it will help you to get in that habit right now. So let me now, without further ado, let's make a program that prints Hello World to the screen. All right. So I'm going to go to File, New File in idle, and that will give me a new window, which will hold a file that I'm about to make. Now, I'm going to save it somewhere so that you can have it later, but you can save this wherever you'd like. I'm going to save it in my desktop, S21 code from class, CSCI 1, and I think this is lecture 12, so I'm going to make a new folder. So just where I put all of your Scratch stuff, I'm now going to put all your Python stuff, and I'm going to save this as hello.py. It's already .py down here, so I'm not going to change that. So it's hello.py right now, and you can see that it's there. Are you ready? We're now going to make a program that prints hello world to the screen. Dun dun dun. Print. And then this is words that I'm about to print, so hello world. Bam. Save the file with Control S, Command S if you're on a Mac, or File Save. And now I can run it. Run module. So I can go to F5 or go through this to actually run this program. That is what I'm doing. Are you ready? It's going to bring it over to the Reppl and run the program. And so here it's saying, oh yes, I'm about to start running this file. And here is the result. Bam, it printed hello world to the screen. Isn't that fun? Okay, it's not too bad. It's just one line. Yeah? Nothing too scary. Now what I did was I called a function, is what I did. Okay, so if I make myself some room over here, I said print and then hello world. Exclamation point, close string, close parenthesis. And what this is it's a function call. What I just did is a function call. Print is called a function. It's the name of the function. And it took something from me so that it could do its job. So I'm saying print hello world for me, please. Okay, so this is called an argument to the print function. These are weird metaphors, I know. It's not like you're yelling at this, but that's just what it's called. And I think I had one too many squiggle in that. Argument to the print function. So that's all. You say the name of the function, an open parenthesis, the argument that you want the function to have and use, and then a closing parenthesis. That's called a function call. It's like this is your friend and you're yelling to him, hey, go do this thing for me. You're calling to him, okay? And you're giving him some arguments as well. You're giving him something to do that thing with, okay? So that is what's known as a function call. It's a weird word, I know, but you're going to get used to it. In general, this is what a function call looks like below. You say the name of the function, then a parenthesis, and then there can be many arguments. As many as you want, and they're all separated by commas. Okay? That's all. And after you're done with those, you have the closing parenthesis. And that is how you call a function. It's quite possible that the function gives back an answer. Okay? And don't worry, I'm going to show plenty of examples of this. Print does not give back an answer, so we don't do this for print. But in general, some functions may give back an answer, and they only give back one. So you can set it equal to some variable name, and we're going to talk about that very, very soon. Okay, so I just want to give you a sneak peek. This is the most general way of calling a function that gives back a value. Okay, if your function, like print, doesn't give back a value, you just say it. You just call it with whatever arguments you want. Okay, so that is our first example. You're Python programmers now. So give this a shot, make sure that it's working for you, and let us move on. Okay, remember how in Scratch I liked to write comments for you, just so that when you looked at the program later, or when I looked at the program later, I knew what was going on. So in Python you can do the same thing, but you have to be careful because Python's going to hope that every line is code. So it's like, hello world. It's going to hope that this line is code, unless I tell it that, oh, no, that's just a comment. Don't worry about that. So if I save this and try and run it, it's going to say, invalid syntax. What are you doing, dude? But you can add comments to Python. Single line comments, comments that only exist for a single line, start with a number sign character. So if I go over here and put a number sign character, you can see how the color changes as well. This is a comment. This is just for the user. Okay? Prints hello world. anything, any line beginning with a number sign, or any part of a line that begins with a number sign even, is called a comment. And the second you press enter, you're on a new line, so you have to re-comment out if you want multiple lines of this kind of comment. Okay, that's all. So that's a single line comment, but this might get tedious. So there's a multi-line comment. You just write three single quotes. I think 3 double quotes also works. But you just write 3 single quotes, write your big long comment that takes up multiple lines, and then you finish it off with 3 more single quotes. That's all. So this is a multi-line comment. So it's in between those things, and here is more Python code. Okay? That's all. So you can write new lines down here. The comment ended there. Okay, so if I run this again, there is no difference between these 2 versions of the program as far as Python's concerned, because it skips. It doesn't execute any of the lines with comments. That's just for us, the programmers. Okay, so those are comments. And now we're ready for the meat. Let's talk about variables, because those are very, very helpful. So just like in Scratch, you can name variables in Python to hold certain values. And variable names in Scratch are very, very forgiving, and you're allowed to like have spaces in between them, but I tried to never use those because I was trying to prepare you for this moment. So variable names in Python have to be very, very specific, okay? You have a lot of options, but you cannot have spaces or special characters in your variable names. Those are off limits because Python gets confused and thinks that you're trying to do something new once you press a space or a special character. It's like, oh, you must have wanted to add that if you use the plus character, something like that. So your variables must start with any of these characters, an underscore, a lowercase character, or a capital character. You have to start with those for your variables. And then, after that, you can have any more of those characters as well as numbers. So you can't start it with a number. Okay, that's another no-no. So for example, here are some valid variable names. X, which is nice. Underscore underscore X underscore underscore. Yes, yes, yes. Underscore blah 42. And hopefully you see how these all match this pattern. Yeah? What you can't do is something like 42 blah. That is a no-no. Not allowed to do that because you can't start your variables with a number. If you put an underscore here, then it's okay, but it can't start with a number. Okay? So the way that you use variables in Python is you create what's called an assignment statement. Okay? Python is just a bunch of lines that hold these things called statements. And assignment statements give values to variables. Okay? All that it looks like is this. So you say the name of the variable you want to set, you give an equals sign, and then you say on the right-hand side whatever you need to say to compute some kind of value that you want to put into this var name. So, for example, let us pretend that we have 2 variables. Let's pretend over here, let's do it in the Reppl actually. Let's pretend that we have the variable x that holds 42, because why not? Oops, there's the Reppl. So I'm going to set x to be the number 42. You see how I'm doing that? And now I can say x instead of 42 because x is 42. Yeah? That's quite nice. So now x is 42. And then y, let's start y off at like, I don't know, 37. That's fine. Dun dun dun. Y equals 37. And you can do fancy things like 37 minus 1 plus 1. It's just going to make sure that this is a value before it saves it. So now it's y, and y is 37. Cool. Now, just like you could in Scratch, you can update your variables as well. You can say, I don't know, y equals y plus 1. And what do you think this is going to do? This is a weird one, isn't it? What in the world is happening here? And I want you to place your bets as to what you think this is going to do, if you don't know already. And let me tell you the secret after I show you what's about to happen. Actually, let's make a file for all this. New file. Let's make sure to save it. Desktop. Code. There. Let's save it as vars.py. So let's do this. X equals 42, y equals 37 minus 1 plus 1. Yeah. And then we can say y equals y plus 1. Okay, if I run this program, it's going to do nothing at all. Oops, there we go. It's going to do nothing at all because I haven't printed anything. I can say x, I can say y, and now, ooh, it's 38. What? How did that work? But I had to say it to the Reppl if I wanted it to print it out. Okay? Alternatively, I could have said print. So, oops, I'm sorry. I'm messing up the microphone. Let's make sure it's actually still working. There we go. Cool. So what I can do is, if I want to print out the value of y as part of my program, I can do the following. I can say print y. Okay? That's quite nice, because now, by virtue of just running the program itself, I go run module, it runs this line. It runs this one, and this one, and this one. It runs all of them, then this one, to print y, which is 38. Okay, so that's what happened with y equals y plus 1. Apparently, it became 38. Why did it turn 37 to 38? Why is this okay to do? Right? So, let's talk about this. Unlike math, where equality is normal, and you could solve this equation and end up like subtracting y from both sides, and then, okay, yeah, 0 equals 1. No. In Python, this is a perfectly okay thing to do. In Python, the right-hand side of your assignment gets executed first. So I'm going to say RHS for right-hand side gets executed first. And that means it's going to calculate this value first. Okay, yeah, it's 38. And then it's going to plop it into whatever variable you put on the left-hand side of the equality. That's what's really going to happen, and that's why it makes sense for this to become 38. You can use a variable to increment itself, which is very, very odd, I know. But now you're well aware of the weirdness. Okay, so that's variables and assignments, and now let's talk about how to get input, because we liked doing that in Scratch. That was how we got stuff from the user, so that our programs can be different every time. So in Python, let's talk about this. In Python, there's this thing called an input function, and as an argument to the input function is the prompt that you want to ask the user. So it's very, very similar to Scratch in that regard. So you can say input, and then you give the prompt. It's like, okay, what is your name? Enter your name. Boop. And I'm going to leave a space for reasons that you'll see in a second. And let's try this. Let's try this in the Reppl. Input. What is your name? Or enter your name. Boop. And I can say Lawton. And it remembers that. It gives back the string Lawton. Ooh, this function gives something back. Interesting. Also, you can see why I added that space there, because if I get rid of it, look what happens to the prompt. Now this is just too squished together. I like that space there. Most people do, I think. So that's what happens. Again, it gets my input and it gives it back in the form of a string, a str. Okay, so because it gives something back, I can say equals something. I can assign this resp variable for response to the result of input, which is that string that I entered. Okay, you see how it's all coming together? It's quite nice. It gives back that result that is the user's response, and that result's type is a string. Even if the user types a number. Let me put that in all caps. Which is weird to think about. So for example, enter your name. we can say, actually, let's just make a new file for this because this is getting a little too much. New file. Save. Oh, it remembers the folder if I do it that way. Cool. Let's say input.py. So now we'll say input, enter your name, and we'll assign the result of that to resp, the variable. And then we can print it back out. Resp. So enter your name. 42 is my name. It really is getting a string, and actually it's not showing it, is it? I do have to do it from the Reppl. You see? It's a string of characters. It's not the same as a number. Because look what happens when I multiply the string 42 by 2. That's not going to work. Okay, so that's this is what happens now. And now we have the variable. We have resp. And if we're normal and I actually follow the rules, resp holds the string that is my name, holds Latin, and that's essentially all that input is about. You say input, and here's your computer. Python prints out a prompt for you. Let's make that. There we go. It's going to say, okay, what's your name? I'm going to move this because it's bothering me. There we go. Much better. So Python's going to be like, oh, your name? Enter your name, colon, and then you type your answer. And then once you hit enter, it has it. It has it and it stores it in resp. Okay, that's the full story. That's all I wanted to say there. So because of that, you can say, all right, you can say back to the user, hi, and then your name. So you can say hello, comma, space, and then you can print their name, which is nice, but it prints it on multiple lines. How can we fix that? Print, the function print, can take multiple arguments, 42, 43, 44, and it puts spaces in between all of them. Isn't that nice? So instead of this, I can say hello, comma, the space happens with that, and now I can say resp. You see that? So if I run this, enter my name, I just pressed F5, but you can go to the run menu, of course. It says hello Latin. Isn't that nice? So hello, comma, and then another argument. In between arguments, you put commas, and then you give the thing that you want to print, and every comma kind of like makes space between these two things, and that is the answer. So we can have it talk to us now. Isn't that nice? So that's getting input. One thing that you might be wondering how to do, just for fun, is how in the world do you put an exclamation point at the end here without there being an extra space? Well, there are two ways to do it. This way won't work. If I say run, watch what happens here. Unfortunately, this is going to print an exclamation point, and maybe I should write this down here. Fancy printing. So print by itself prints out arg1 plus a space plus arg2 plus a space plus arg3. Okay, those commas automatically generate spaces. That's what I'm trying to say. If you don't like those spaces, you can use the plus operation on strings. So like hello, comma space. Oh no, plus resp. We wanted the space there and we included it ourselves. Plus, and then an exclamation point without any other spaces. So these plus operations will solve the problem for us. Okay, so let me show you that. So we don't like this way. Before exclamation points. But if you're French, you do. You love those, okay? I'm sorry, but we unfortunately have to speak English right now. So the way to get around this problem is to say hello, comma, space, plus resp, plus, then the exclamation point. And you can mix and match, sorry, those commas, and that will do what you want. Okay, so this one's going to be nice. Doesn't have an extra space. Okay, so running that, if I type my name, that's beautiful. See how it did it the English way and not the French way? Very nice. Okay, so that's input. Hopefully that's fun. And now you know how to print things fancily. The last thing that I want to show you, in terms of Python at least, is the math library. Okay, so this word, it's a weird looking word. It's another metaphor. There's tons of those in programming. But the idea is, think of it as like a real life library where you want to go and learn things and gain knowledge, right? So a library in programming is just a bunch of pre-written programs, okay? A bunch of code that's been pre-written for you. Pre-written code that you can use inside of your own programs, okay? Okay, so that's what a library means, and so I want to show you the math library. So let's go there. Dun dun dun, this is what it looks like, and you see all these fancy things. These are all the different functions that the math library gives you, and like it does the factorial function for you, it does the greatest common divisor of numbers, it does, I don't know, finds permutations, let's see, raises e to a certain power, it's the logarithm, all of these things that I'm sure you don't want to know how to do yourself in programming. Those take a while, like square root. It's a weird program that calculates the square root. Maybe one day I'll teach it to you. So cosine, tangent, sine, things like that, all those things that you would like to have been made for you already. So that's the math library. And if you want to use the math library, you have to import it. Okay, you have to say import math to use the math library, and that's going to be the first line of our new program. Okay, so let me show you that. New file, let's call it math.py. So we say import math, and this lets us use math's functions. And every time you want to use a math library function, you have to prefix it, okay? So you have to say math dot, whatever you want, okay? There's always that dot. It's usually the case when you import something. You always say the name of the library, dot, the name of the thing that exists inside the library that you want to use, like thing inside the library. Okay, so yeah, that's how we do it. Math.py, for example, that's just a variable, but it's a variable that we have to qualify. It's like, okay, it lives inside the math library. Okay, so we print it out like that, run it, and bam, we have this very nice long version of pi. Isn't that awesome? So that's math.py, but there's also plenty of functions like square root, and if we want to use it, we say math.square root. And this is a function, so we can give it a number. Please print out the square root of 2, please. And there it is. Isn't that fun? And then, of course, you have your sine, cosine, and tangent and things like that. So it's like, okay, print math.sine of math.py. Hoo-hoo. What's that? Well, it's a very small number that's very close to 0, and this is not the place where I wanted to tell you this unfortunate fact, but floats are not exact. This is very close to 0, but not exactly 0, sadly. I guess you had to learn that today. Math.sine of 0 is going to be 0, of course. And so that one was exact. That's nice. How about math.cosine of 0? Very nice, very nice. So that is the idea. Okay, is there anything else that I'd like to show you here? We can generate pi if we wanted to ourselves. I think we have the inverse tangent function here. Atan is the inverse arctangent. And so I think if we do math.atan of 1, that gives us pi over 4. And if we multiply it by 4, we get pi back. So maybe that's how they're calculating this math.pi variable. Who knows? One way or the other. So that's the math library. Hopefully that was fun. And that's essentially where I would like to leave you today. So that is everything. So please explore the math library. If you'd like to go back to this table of contents where you can see other libraries, I encourage you to do that, because the more things that you know how to do, the easier your life is as a programmer. So that is the math library. And then, that's right, I did want to do one last thing, sorry. Let's go to Python Tutor very quickly. This is a website that's going to save your life. So let me take a program, like, I don't know. Dun dun dun. Oh, I closed the ones that were useful, didn't I? Let me open up one. How about vars? Yeah. So let me take this program. I'm going to copy it. I'm going to copy it right here. So this default one is perfect. We want Python 3. Doesn't matter the point whatever. What you can do on this website is watch in an animated way how your program executes. And it's the greatest thing in the world, and you're going to love it. Okay, so if you click Visualize Execution, and I encourage you to always come back here once you learn something new to see exactly how something's working. Because this is going to be very simple, but the second we learn like if blocks, in Python they're called if statements, it's going to look very nice. So here is our program. I am going to zoom in for you. And you have all these buttons. So here is where your output's going to be put once it prints something. Then you can say next. You can also go backwards in your program. But here is it showing you exactly how your program is going to be executed. And this is great as you're learning how to do Python. Okay, so the first line is x equals 42. That's going to set the variable x to 42. But if you didn't believe that, you can just press next and watch it go to the right before the next line. And notice that, oh, yes, it made it an x variable. That's how it's drawing. It's almost like a box. So it made the x variable, and its value was 42. Shoot, that's perfect. That's exactly what we wanted here. And then it's ready to execute the next line. So you can say next. Bam. Yeah, y is 37 now. That's right. And after this line, y should be 38. Oh, yes, our intuition is correct. And now it's about to print the line. Print y. If I click next, you can see how it goes to print 38 into the output box. And now the program's over, so I can't click next anymore. And this is the ending state of our program with x set to 42 and y set to 38. And this is just a great way of just confirming that your intuition is correct. Or if you're not so sure about how something's supposed to execute, just bring it into here, bring it into Python Tutor, and it will tell you exactly how it's working. Okay? So I definitely encourage you to use this as I talk about more Python. It's a very, very useful website. Okay, so I think that is officially everything. And yeah, hopefully Python wasn't too bad. I know it's a bit of a jump. It's a bit different, but it is still very similar to Scratch, I think. So yeah, that's where I want to leave you with that, and I will see you next week.